Okay, so on to our third challenge speaker this morning, Simon Thomas of Thales UK, who's a software development and integration manager, who's going to be speaking about his top verification challenges. Simon has worked in the software industry for 17 years with a specialism in command and control systems. He has run both small and large software teams to deliver both in-service systems and cutting-edge research and development. Simon has spent the last 3 years working on unmanned and autonomous systems within the naval domain. So, hand over to Simon.
Okay. Okay. For those who don't know, very briefly, Thales Global, rather than just Thales UK, covers anything from air traffic management to in-flight entertainment to security to transportation. But I don't do any of that. I work in defence mission systems, more specifically maritime, and we're based in Manchester, but for the observant ones, Manchester doesn't have any water around it, apart from the ship canal. So I end up travelling a lot over the UK, South Coast, Scotland, and globally for sea trials and activities open water. Compared to everyone else, I've been living the dream for about 3 or 4 years now in terms of software. We started a research and development activity in about 2013 in unmanned vehicles, and we built an unmanned surface vehicle, which is on the right. This is Halcyon. And we started developing software and using COTS hardware to deliver capability fast as a demonstrator to potential customers all around the globe. So what does that mean? That means reduced life cycle, minimal requirements, minimal test and validation. Let's get it out there and let's show our offerings in the shop window. Absolutely brilliant. The softwares have loved it. I tell you, it's been great. Fortunately or unfortunately, it is perceived to be at a level of maturity and robustness, so your demonstrator turns into the thing the customer wants. And they want it yesterday because they've seen it, they've touched it, they've played with it, and it works. Okay. So what we do in terms of autonomy is we have a behavior-based autonomy engine, and this is simply on the left. A condition may happen and one or more behaviours may be executed based on that condition. Behaviours have priorities, they have senses of urgency, and when you do a one in, one out kind of scenario, it's all dead simple. We know what's going to happen. We have something magic down the bottom, which is either the action selection or the solver. The solver can actually take multiple inputs and multiple priorities and then determine actually what to do. So it was great, it's dead simple, but suddenly we realised that we haven't just got one environmental input. We've got 20 sensors as a minimum. Those 20 sensors can all provide something different constantly. The differences can actually see the same target if it's a collision avoidance sensor or radar or the likes, but they can actually see it from a different trajectory, so they can get different statistics. And how do we start to determine what's the right behaviour, what's the wrong behaviour, and actually what priority needs to occur? But none of this matters in a demonstrator because we've got a man on the boat that's like that. He's not touching the helm, and we hope for the best. So we haven't had the problem. Okay, we have had the problem, but we haven't acknowledged the problem. I don't sleep at night worrying about this, and I haven't done from the start because of my experience, my limited experience. I'm quite young. I know this was coming. I really did. Luckily, I worked with some really good engineers who also had the worry bead as well. So we would text each other at night and discuss it and do those sad things. And I presented at a conference about 2 to 3 years ago where luckily Mike was there and then Kirsten from Bristol, and they decided to open up a counselling session for me on my problem. So what we did, we started an Innovate UK task. I think it was last year, but time moves so fast that you lose count. And not to go through the detail, but this, if we look at those behaviours and actually the software architecture of that autonomous engine, it's the big blob in the middle, okay? And Mike was looking at taking hardware verification techniques that they use for things like system on chip, and could we apply it to software? And they've done some experimentation, but they wanted some real world cases. And this was for me a great one, because it was a potential start to solve our problem. And this is what we've been doing over the last year. So we have a software environment where our autonomous engine is running. It comes with a great simple UI to see what's happening, and we can feed in multiple sensors, multiple inputs, and build it up over time. And what we are doing at the moment is applying pseudo-random testing in its first form to see what occurs. I don't believe this is going to solve the software problem at all, okay? But what it's doing is it's giving us an insight into the problems that we might face going forward. There's a big problem with this though. When I listen to the guys like Mike from Rolls-Royce and stuff, and we quote DO178 and the likes, it might be heavyweight, it might be complex, but you've got a standard, you know what you're trying to achieve, and you know what you're trying to work to. We have no standard. In the maritime industry, there is no legislation for autonomous vehicles. None at all. So at the moment, there's a game where we need to do as much work as we can and a much validation and safety, and propose to IMO, the International Maritime Organization, the likes, what we are doing. But ultimately, in 1 year, 5 years, 10 years, when they actually agree what they're going to do, we're going to be hit with legislation, and we don't know if our system is going to be suitable or not. We might have to start all over again. That's the reality of the situation. So what do? We acknowledge that unit testing and kind of scenario-based testing, and when I talk about scenario, I'm talking about the old-fashioned, a guy sits at a desk and pushes buttons and sees what the result is. We know it's not good enough. We've also been spending a lot of time looking at synthetic environments, actually creating 3D worlds of maritime environments, and then integrating our capability into that, and running multiple scenarios. The problem is, a lot of people get carried away with the 3D visualizations and how nice it looks, rather than actually the value it's bringing in terms of validating, qualifying our software. Plus the fact the tools that you're using, the synthetic environment and everything, aren't qualified themselves. So how can you say that that's good enough to test your own capability? We're also worried about one platform and one autonomous engine at the moment, but we're under immense pressure to be building up swarms. Now, I don't like to use the term drones because it comes with an awful connotation because of the media. But if I do use the term drones for simply, you know, we're talking about having multi-assets, multi-payloads, multi-capabilities all operating in tandem. The idea from management is once we have two talking together, it's just a level of scale and we can have 100, so it's all dead simple. But then they've got to collaborate and they've all got to see the same problem or the same target from different aspects. So you're magnifying the problem. How do we validate that? We haven't got the answer. The fact is I haven't got an answer, and this is a problem session. What I'm doing is telling you my problem. And as I said before, there's no IMO, there's MCA regulatory compliance at the moment. You know, SOLAS, Safety at Life and Sea, is brilliant. It's a really thick book, and I've read it, and it's very, very interesting. But it's all based around having a captain or a master who makes the overall decision. And in an unmanned vehicle, you don't have one. So who makes that decision, and suddenly does that autonomous engine have to behave like a human? That's the reality of where we are. It all comes down to the safety case. We've got to meet the safety case, and at the moment we don't know how we're going to do it. And finally, I've got more problems on top of that, because already we're trying to deal with behavior-based control, but we know very shortly that's going to be old-fashioned. It's happening now. AI, real artificial intelligence, is coming, and we are starting to work on some of that in terms of actually We won't do, the boat will do something where it determines the right thing to do. We can't actually get the right answer every time. We don't know what the right answer is going to be in terms of it will definitely do this. What we will know is we'll set a challenge of do not hit something, and it will then act around it. So we have simulations and we are developing the capability, but it's very, very early, and we haven't even cracked the behaviour one yet. What do we do about verification? Mike's helping us start it, but it's step one on a massive, massive journey, and that's my problem space.
Thank you, Simon. Thank you very much. Thank you. Me and Kirsten are still available for counselling. It doesn't sound as if it's worked yet. There's still some distance to go. Do you have a question? Yeah, Roger.
Roger Shepherd, Chipless. It seems to me that you're listing a number of things that appear to be technical challenges, but actually it seems to me that maybe your big challenge is how to educate your management about how difficult the systems you're trying to construct are and why they shouldn't be building them for another 50 years or so.
They are building them because the customer community is asking for them. You know, your customers are asking them, and this is it. And there's a number of companies all competing against domain and working together and the likes. I'll be honest with you, we have a number of challenges on the development side of things, and if we looked wrongly at the traditional waterfall approach, verification is going to come later. Let's worry about that, you know, after we've got something to verify. We need to be thinking about it at requirements level and how we're going to sell off what we're actually doing. They've got issues in terms of the capability we have to supply, not just in terms of autonomy, in terms of communications, security and everything. And they're the focus of attention today. And that's my issue because I'm losing sleep over the other end.
We need to help you sleep, definitely. Okay, thank you very much. Thanks, Sam.